Welcome back, everyone. Today we're doing another Kuta software worksheet tutorial. Today we're doing percent change. There are a ton of misconceptions about percent of change, and a lot of students get mixed up with some other percent concepts. So we're going to try to break it down in this video into the simplest way possible. Let's go ahead and get started. Now, before we even jump into number one here, from 45 feet to 92 feet, we're asked to find how much this increases in percent. Okay, before we get into that though, I kind of want to break down what happens if the feet, whatever this is talking about, okay, if we're talking about the distance of, I don't know, a runner or something like that, percent increase, if it stays at 45 feet, okay, so I like to call this the original. I like to think of things as the original and the new. So then we'll make new green. So the original and the new. So if the original is 45 feet and the new is 45 feet, what happens here? Well, there is a 0% change. Now, this is very important that you notice that the word change here. So it's a 0% change. That means it didn't move up, it didn't move down, it stayed the same. Now, this is what confuses students and basically everyone, adults, whoever. There's a lot of misconceptions about this in general. The percent of the original, of the new to the original is still at 100%. What does that mean? That means it still maintained all of its value. It didn't increase, it didn't decrease, it's still 100% of the original. Okay, notice what I said there. The new is 100% of the original. Okay, and I think it's important to write this out to see the language. Okay, so we're going to write this and we're going to make this, let's make it blue. Okay, so the new is 100% of the original if it stays the same. Now, what does that also mean? That means that the new had 0% change from the original. Very slight difference, but it means a completely different thing. So it had a 0% change from the original. It is 100% of the original. So it maintained its value. Okay. What's another way of thinking this? Well, whenever we're doing operations with percentages, we never want to just work with the percent itself. We want to change it to its decimal value. So how do we change 100% to a decimal? Well, we just move the decimal place over 2 times to the left, so the decimal form is 1 or 1.0, whatever you want to say. So 1.0 is the decimal form. Now, a way we can verify that when you go from 45 to 45 and that there's no change is you multiply by the percent. Okay, so you multiply by the percent. 45 times the decimal form of 100, which is 1, is still 45. So if you multiply by 100%, it doesn't change. Multiply by 1, it doesn't change. Okay? That's one way to think of it. So pause this if you want to take these notes. I'm going to erase it. Okay. So if there's 0% change, that means we're not adding anything to this 100%. We're not subtracting anything from this 100%. So we're not adding any percent there. We're adding 0% to that. So that's what this percent change. We start with our 100% and we say, okay, does it change? We're going to add or subtract to that 100%, okay? So this is just a framework for understanding how this works. Now let's expand it just a little bit. So we talked about 100% of the original value. So this is 100% of the value. Okay, let me make this a different color, style, orange. Okay, so that's 100%. What if we have, okay, here's our original 45 feet, and what if we go under 50%? Okay, under like, when are we going to start the problem? I just want to have this as an explanation to help you understand. So when do we go over, when does it apply 50%? What does that mean? Well, hopefully you understand that if we have 50% of something, we have half the original amount. So if we wanted to, we could change this to a decimal. 50 to a decimal is 0.5. We move the decimal over 2 times to the left. So we do 45 times 0.5, and what do we get? We get 22.5. Okay, so 50% would be 22.5. Okay, that's essentially, think of the word half. So we're going to make it by It's going to be half the original amount. So the new is half the original amount. The last example I want to go over is 200%. What happens if you have a 200%? Like the new value, okay, the new value is 200% of the original. I should change this to blue. Okay, it's of the original. I'm not talking about percent change just yet, okay? But I just want to understand of the new amount, how much of a change is it? So if we started at 45, this is your original amount, and we had a 200% increase. Well, the decimal form of 200 is 2. So we multiply this by 2, and we're going to get 90 feet. Let me change this to feet. So think anytime you see 200%, that is double. So 200% is double of the original amount. Okay. Now, what would the percent change be? Well, this would be a decrease of 50%. Okay, we went from 100% to 50%. Okay, so that's why that is. Let me make this. That's fine. So that's why that is. Whoops. Decrease of 50%. We went from 100, and this is an increase of 100%. So we went from 100%. This was our baseline. Okay, and we increased to 200%. That is an increase of 100%. So we did percent change, and we did a percentage of the original, both at the same time. So we get an idea of what does it mean when we have a percent change. Okay, now we're ready to do the problem, and I'm going to do it over here to the right. I really want to leave this because this is super important. Okay, so let's do this in pink. Okay. No, we already chose that color. Let's do this dark blue. Okay. Now, our original is 45 feet, okay? But our new is 45 feet, or excuse me, 92 feet. So how do we figure out the percent change? We talked about what it is, but we didn't I didn't go over how to calculate the percent change just given the amounts, okay? To do that, what we do is we first find what percentage the new is of the original. How do we do that? Well, to find the percentage of original, okay, we're going to use the original as the baseline. The original as the, what's a good way to say this? As the whole. So the original will be on the bottom. Okay? And then we're going to put the new on the top. So we take the new, we divide that by the original, and that will tell us what percentage the new is of the original. Okay? So in this case, we're going to take 92. Let me move this down. Okay, we're going to take 92. That's the new. We're going to divide by the original. Okay, oops, not the original. I need to write the actual value. 45, that's right. And that will tell us what percentage. This will not tell us the percent change. Okay, this will tell us the percentage of the original. Okay, so we do 92 on our, you can use your calculator for this, by the way. 92 divided by 45, and we get 2.04. Okay. If we want to say this as a percentage, we can easily calculate this as percent. This is 204.4 repeating percent, but I'm just going to round it to the nearest tenth, 204.4%. That's what the new is of the original. The new is more than double. Okay, remember, double was a 200% increase. The new is more than double than the original. So what is the percent increase? Well, in order to find the percent increase, we always take away 100 from this. So you're going to take away 100% to find the percentage increase. Okay, so let me should turn this to green. Style green. Okay, so I take away 100% because that's our baseline, so we can see that's what the original amount is, and this will tell us our percent change. So this is 104.4%. Now it's a positive, so that means it's going to be an increase. So this is an increase of 104.4%. Okay? This would almost be a great place to stop here. But let's do a couple more examples. Let's do 74 to 75. Notice how these are very similar. So here's our original. Here's our new. Okay? what are we going to do here? Always take your new divided by your original. So we take 75 and we're going to divide this by 74. Okay, so let's do some pre-work strategy and thinking. So if it's 75, 75 is bigger than the original 74. So we know it's going to be a percent increase, but it's only going to be a small percent increase. So let's go ahead and do the division here. We have 75 divided by 74. Remember, this is not telling us our percentage increase. This is just telling us what the new percentage value of the original is. So this is 101.4%. Now, that's the percent of the new from the original. So we subtract the original percent, which is always 100%. And we see that we have a positive. Positive means it's going to be a positive change, a positive 1.4% increase. Just as we predicted, we knew it was going to be increase and we knew it was going to be small, only 1.4%. Okay, now let's move on to the next one, number 5, miles. So we have 94 to 34. Okay, this is going to be the last one I do because I want to keep this short, and I think you'll be able to do the rest from here. So here's the original. The new is 34. Okay, look here. The new is smaller than the original. That's a big red flag for us that something's a little bit different this time. So we're going to take 34 divided by 94. Notice how if it's going down from the original, that's going to be a decrease. We're going to see how that plays out in just a second. So we do 34 divided by 94. Go ahead and type that in your calculator. Look at this. I get 0.362. Actually, I round it. Let's make this into percent. This becomes 36.2%. Now, that's not the percent increase or decrease. This is just the percent that the new is of the original. So how do I find the percent change? Well, I subtract the original amount, 100%. Okay? Once I do 36 minus, let's see how that's, give me a moment, minus 100, okay, this is the cool part. I get negative 63.8%. A negative. Now, if it's a negative after you do the subtract 100, guess what? That means it is a decrease of 63.8%. So this went down 63.8%. And there you have it. This is the basics of how you calculate percent change, the percent of the original. Kind of with this whole situation here, this whole setup, you should be able to do any problem that you encounter with percent change. Hope you found this helpful. Thank you for watching.